final week, right? We'll meet that last time to play our games, right? It'll kind of be fine because you'll just come in and we'll do some stuff in class. But the stressful stuff will end.
Excuse me, can you play this thing for me, please?
Sound good?
Thank you.
Can you handle that?
No, up there. Up there is good.
And we'll be good.
Thank you.
All right. So today we're going to talk about pointers and get eventually to a point today. You love to get eventually to good stuff, right? Where they're actually useful. Okay, but we need to kind of introduce them and do some baby steps with them before we get into where we move. Sound good? Pointers, right? Maybe after this, you're like, no, I don't like it. All right, this semester, I won't make you cry with pointers. Next semester, if you keep going on, probably you'll cry a little bit.
Don't let Boyd make us cry.
All right, here, I'm going to let someone else, right? I'm the nice guy, he's the good guy. Anyways, the pointers for us this semester will be too bad because we won't be doing much with them as far as organizing them. Algorithms 2 takes pointers and what they're pointing to and organizes them in structures, and that's where it gets crazy. Now, got lots of things pointing to lots of other things which goes on. You're like, well, that doesn't make any sense because we don't even know what pointers are. All right, let's talk about pointers. Right? Pointers are a way for us to get more control over memory in C++. Okay, so we get control over, right, seeing where things are in memory, and kind of variables can now hold where things are in memory, right? We talked about this a little bit because we talked about memory addresses and how every variable that gets created is stored in memory in some location. Good? Right? So, in essence, we get these things called pointers, right, that hold the memory address of a variable. Normally, variables hold values, right? They hold integers, they hold doubles, they hold characters. All right, everyone good with that? Right here with pointers, we're saying that they don't hold, right, values, they hold memory addresses. They say this is where a variable is located, as opposed to this is the value of the variable. Does that make sense? So we call them pointers because they point to a variable as opposed to hold the value, right, of an integer or double or whatever. Make sense? Right, anyone know where we've seen pointers before? Call by reference, right? Call by reference, we put the ampersand. And we said that the argument being passed in, right, was really the memory address of the variable, right? Are you good with that? Call by reference. Anywhere else? Not strings. One of the things that you're doing a lot of it right now.
And the parameters.
On parameters. Arrays, right? Because what do arrays store? The first memory address of where the array is. Okay. We've been saying the first element, right? So arrays are the other, right? So really, array variables, right? The array variable holds a memory address of where the array is. So in fact, I've been lying to you about how arrays look, and so today I'll draw what they actually look like. I like to lie a lot, so. But then eventually I'll tell you what's really going on. Maybe you can, but your grades dependent on it, so you both of these, right, have been handled automatically, right? We created it, right? I call by reference, I pass it the argument, but then in the function, I just use the variable like normal, right? And it's smart enough to know, oh, it doesn't go here, it really goes there. Right? Arrays, same thing, we use square brackets, right? It just works. And today, we're going to learn how to do it more manual, where we're going to create variables, right? Have them point to the variables and put values into something. All right, so let's talk about this, right? So pointers, right, can be variables. Basically, you can store memory address in pointer variables, okay? They have their own type, okay? It's not an int, it's not a double, it's not a character, right? It's a pointer to an int, or a pointer to a double, or a pointer to a character. And so we just do something like this. Double P, which we're used to doing, but you'll notice that in between I stuck a star in there, right? And this says do not create me a variable P that holds a double, but create me a variable P that holds a memory address of a double, right? So this is technically a pointer variable, and it can store the memory address of where a double exists. That make sense? We're kind of good there? Right? Now, it is a double pointer, so it doesn't point to integers, it doesn't point to characters or strings, right? It only points to. All right, so declaration right, we just put a star on the identifier, and that says that this variable is of pointer type as opposed to regular type. Okay, how many variables did I create here?
4.
I know some people said 2, but really I created 4 variables, right? 2 variables are just integer variables, right? They hold integer values, and 2 variables are what? Pointers to integers, right? So they can point to integers. We have 4 variables, 2 pointers, and 2. Good so far? Right? Where's the verbiage gets a little wordy, right? But let's see if we can follow this. If P1, right, which is a pointer, if it holds the memory address of V1, then we say P1 points to V1. Right? And I'll draw it here in a second. Is that right? If my pointer holds a memory address to a variable, then it points to that variable, and that's why we call it. Yeah.
So if you're initializing, you would say if P1 equals 12 or something like that.
No, because it doesn't hold anything, right?
You would say if P1 equals P1.
You can't say V1 either, because V1 holds an integer as well. We'll get to that. 4 variables, right? P1, right? I'm not going to do the other one, but you get P2, V1, V2, right? Now, V1, I'm going to say its type is int star, right? Because it holds a pointer to an integer, right? And we'll say V1, right? Its type is what? I'm not making that up. That's its type, right? It's an integer. Everyone good there? Now, what we normally don't draw is that, in fact, these variables get stored somewhere in memory. Agreed? So technically, this one's at some memory location. I'm just going to say 0x1. Right? And we're just going to say that this one's at 0x2. Good with that? And so, right, if P1 points to V1, then P1 holds the memory address of V1. And so the memory address of V1 is what? All right? And so P1 can hold, right, 0x2. Does that make sense? Right? But really what you'll see me draw it as is it's a pointer, so we'll get an arrow, right, that points to, right, the variable of the memory address that it holds. Does it make sense?
If itself has a address which determines the location.
Yeah, right? Every variable you create, whether it's a pointer or not, it has a memory address, right? It has to be carved out of memory somewhere. But we're saying that an int star can only hold memory addresses of what? Ints. You basically take a star off. Right? Ints can't hold memory addresses, right? They have to hold values. Make sense so far? All right, let's talk about how we can make this happen, right? Because right now we don't know how to assign values to pointers and that kind of stuff. So let's talk about the operators, right, to do that, right? Operators are symbols that do stuff. So let's look at those. So we've seen the ampersand called by reference, but you can use the ampersand also to get the memory address of a variable, okay? So you put an ampersand on a variable, you get the memory address where the variable is located. Make sense? So I can do something like this. All right, I'm going to have to draw the same thing again, right? I get a variable called P1 that is an int star. Everyone agree? Right? And then I get a variable V1 that is a what?
Int.
An int. I'm not going to write it, but they both have memory addresses. Right? The memory addresses don't really matter. I don't need to know what the memory addresses are. But let's talk about this. Right? Everyone agree this is an assignment statement? And so I'm assigning something to P1. Well, P1 is a pointer, so what does it hold? Memory addresses, and only memory addresses of what?
Integers.
Of integers. Good, right? And so ampersand V1 says, give me the memory address of V1. So ampersand V1 evaluates to the memory address of V1, and we store that in what?
In P1.
In V1. And so in essence, what am I really saying here?
You're assigning whatever values in P1, or in P1 to P1.
Not the value inside of it, but the location.
Location.
Right? And so to do that, right, we just draw an arrow. right? What we're saying here is point P1 to V1. Because P1 gets assigned the memory address of V1. Does that make sense? So now there's actually two ways to get to V1, right? We just say V1, or we could say the variable pointed to by P1. Does that make sense? Now, to get, right, we know how to do this, right? V1 equals 5, right? We know how to do that. But you can actually now use the pointer, because the arrow goes there, to also store values in V1 via P1. Does that make sense? So I can just directly put stuff here, or I could say, come here, follow the arrow, and put stuff there. Okay? To do that, we use a new operator called the dereferencing operator. Okay, the dereferencing operator, which is also a star. Right? We use the star declaration to create it, but now we can also use the star to dereference. Okay, and that says, get me to the variable pointed to by the pointer. Give it to the variable pointed to by the pointer. So let's look at this example. Star V1, V1, V1 gets a 0, so I'm going to put 0 here. P1 gets assigned the memory address of V1, right? P1 gets the arrow that points to V1. Are we good there? Right, so let's talk about this. Kind of looks weird. Star P1 gets assigned 42. And that says, put 42 into the variable pointed to by P1. Put 42 into the variable pointed to by P1. And the variable pointed to by P1 is what?
V1.
V1. So instead of 0, what is it?
42.
42. So in essence, right, the name of this variable is V1, but it's also what?
V1.
Not P1, but
Star P1.
star P1. Right? The name of that variable now is also star P1. Okay. I always say you follow the star road. Right? Follow the star road down. Sounds like a Mario Kart thing. Follow star road. Right? From your pointer to the variable that it's pointing to. So when I output V1, what do I output? 42. When I output star V1, I also output 42, because V1 is the variable, but star V1 is the variable pointed to by V1. That makes sense? Now, pointers are variables, and so if you create two pointers that are both n stars, they have the same type, which means I can assign one to another, right? Because things that share the same type, you can assign things back and forth. Agreed?
Yes.
So let's continue this example. I'm going to create another variable, right? P2, which is also an n star, right? It starts out with garbage, just like everything else starts with garbage, right? Kind of interesting. Pointers start out with memory address garbage, right? Integers start out with integer garbage. Right, so this has some random memory address in there, right? What does this mean? P2 gets assigned P1. What am I saying?
Find the memory address of where P1 is.
The value of P1 can be the value of P2 now.
Right. And that's what my hair is saying. He's saying that P2 gets the memory address stored in P1, right? And the memory address stored in P1 is really an arrow, if you want to think of it that way. So how am I going to draw it?
An arrow up
Up to where?
to V1.
Right, up to there?
Yeah.
Like you point to the same spot that your other one points to.
So if you move the value, does P2 still have the same value before it takes away?
What do you mean?
So like if you're moving the value to P1, if P1 is equal to P2, does P2 still have that same value?
Right now, yeah, he said P1, let's get assigned to 2, yeah, that will be the same.
Okay.
It's like two variables, but both have 5 of them. Which means that the name of my variable is V1, it's star P1, and it's also what? Right? Because if one name for a variable wasn't enough, might as well just give it 3 names, right? So when I see out star P2, what do I get?
42.
42, right? Does this make sense a little bit? Assignment of Pointer variables is assignment of memory addresses, right? You're copying an arrow from one box to another box. And so we're going to go through the difference between assignment of memory addresses, P1 gets assigned P2, and assignment of what they're pointing to. And we're going to look at how this is going to be a little bit different. How many variables do I create?
4.
4, right? P1, P2, right, both of type int star, right? V1, V2, both of type what?
Int.
Everyone good? Right? Right now in the back of your mind, you have the question, why would I use a pointer when I can just use the name of the variable? Just throw that off to the side. We'll answer that in a minute. Just stick with me. So when I say V1 gets assigned 0, 0 goes into where? V1, right? You should be able to do that.
Yeah.
I hope. V2 gets assigned 5, 5 goes into
V2.
V2, easy enough. All right, some of the new stuff. P1 gets assigned the memory address of what?
V1.
V1. In essence, what? P1 points to
V1.
V1. Good? Did I tell you I was super excited to like draw on the board, right? P2 gets assigned the memory address of V2, so P2 what?
Points at 5.
Right there. Perfect.
Or V2.
And then we're saying do not confuse P1 gets assigned P2 with star P1 gets assigned star P2. All right, so let's look at both of those and see what happens. When I say P1 gets assigned P2, it's assignment of what?
Memory address.
Memory addresses, right? And so we're saying P1 gets assigned the value stored in what?
P2.
P2, and the value stored in P2 is this arrow. Right, so I'm going to copy that arrow into what? P1, right? Which means that P1 is no longer going to point to V1, where's it going to point to?
Boom.
Does that make sense? Right? So structurally behind the scenes, something's happened, right? Because now I have 3 ways to get to V2, right? Star P1, star P2, V2, and just 1 way now to get to V1. Does that make sense? Right, that's assignment of what? Memory addresses. It changes where the arrows are pointing, right? When you do assignment of pointers, you're changing where the arrows are pointing. All right, let's have the stars on here. Right? The stars say to do what? Follow the arrow, right? Star says to follow the arrow. So we're saying the thing that P2 is pointing to, that value gets assigned to what? The thing P1 is pointing to? Does that make sense? The thing P2 is pointing to gets assigned to the thing that P1 is pointing to. Well, the thing P2 is pointing to is what?
V2.
V2, whose value is?
5.
And that gets assigned to the thing that what? P1 is pointing to, right? Which is?
V1.
V1, right? So no longer is this 0, right? What is it now?
5.
5.
Does that make sense? Did my arrows change? No, because I did not do assignment of pointers. I did assignment of what pointers are
Pointing to.
pointing to. Are we confused yet?
A little bit.
Right? Pointers are a lot easier when you draw them. Draw that out.
So what errors would you see if you just said P1 equals V1?
So if you said V1 equals V1, you get a compiler error saying that the types don't match. It says something about you can't store, in this case, an int into an int star. All right, let's write a little bit of code. Or how about I'll write a little bit of code and you guys watch.
Deal.
How's that sound? This is like the time that in class you're like, oh great, I can take a break, I can take a little nap. Or you're just gonna say some stuff, and then move back. All right, int star P1, comma star P2, right, and int V1, comma V2. Right, once again, I created four variables, right? 2 are pointers and 2 are What are the variables? I'm gonna see out P1, a space, and P2, and V1. See what kind of output we get. You'll notice that, right? One of them I got 0. We'll talk about the 0 next class. Right, but the other one you see is 0x and then a bunch of numbers.
That means
right?
memory, right?
Right, so that's a memory address, right? Because P1 is a pointer, they hold memory addresses, right? And that memory address is garbage, right? Because I haven't assigned it. But what I can do, right, is I can say something like P1, right, gets assigned the memory address of V1. Right? So let's give V1 the value of 1. Let's give V2 the value of 2. So now I can output P1 and I can output star P1. P1 holds what?
The memory address.
Memory address, right? So when I output P1, I'm going to get a memory address. The memory address of what? Of V1, right? When I put star P1, right, I get the value that the pointer is pointing to. Right? Which should be what?
P1.
1.
Or 1.
Right. V1's value, which is 1. So the first number, right, is the memory address of where V1 is located in memory, and then the 1 is the value that is stored in V1.
Still looks like garbage.
It still looks like garbage, right? Yeah, it still looks like garbage. All right, you'll notice though, if I outputted like, right, I might as well do this, right? V1, let's output ampersand V2. Right, the memory address of V1 basically, and the memory address of V2. Notice that while the memory addresses look like garbage, they're close together. Right? And in fact, they're 4 numbers away from each other, right?
Yeah.
Which is actually telling you that in this instance, integers take up 4 bytes. Right? It's because each integer got made and they're 4 bytes away from each other. Does that make sense a little bit? Are pointers variables?
Yes.
Right, I put star P1 and ampersand V1. Yeah, you'll get the same. I'm going to get the same number back. Why did star? No star. Because, right here we said P1 got the memory address of V1. So when I put P1, I put ampersand V1, I should have said it. It's like saying, right, variable, right, V1 gets assigned a 5, and then I put V1 here, and I put 5 there, right? So match. All right, you guys answered correctly. What did I ask you? Oh, is a pointer a variable?
Yes.
Yes. So does a pointer exist in memory?
Yes.
So can I say ampersand V1?
Yes.
Yes. You can. Right, which gives me the memory address of where that value is.
So pointers have their own memory
right?
address as well as another's.
Yeah, right? Because, well, all variables have a memory address, right? I was writing it on the board earlier.
Right.
Right? But pointers can also hold memory address.
So it takes up more space than usual.
No, less space. Pointers take up less space.
But it just has two. It has 2 spots now.
Well, the box still only takes up 1 spot.
Mm.
It just stores the location of where another box is. The source just takes up 1 spot.
Okay.
Alright, let's not add that in. Okay. Questions? Right? Once again, the question that is going in your head, but you're too nice to ask, right, is why the hell would you do this?
Yeah.
Right? Because if we could just create V1 and V2, why would we do star P1 and star P2 and point to each other and all this fun stuff? Right? So I'm going to take away V1 and V2, okay? Meaning the only way you'll be able to get to these variables is via a pointer. All right, you ready for that? I was gonna be like, why are you taking it away? Something mean like that. So let's talk about dynamic variables. Dynamic variables are variables that get created at runtime. Okay, while your program is running, you can actually write code to create variables, and next week we'll learn how to then actually delete the variables. Okay, so these variables have no identifiers because they're created like while the program is running, right? Not kind of in the, right? We're going to use a word to create them so they don't get their own names. So we have to store them into pointers as the only way for us to do it. To do this, we use an operator, a new operator that's called new. It's the first operator we've had that's not just symbols, but new is technically an operator. Okay? The new operator allows us to create these dynamic variables, these variables that get created at runtime. No, they're just keywords, they're not operators. Operator means that you can overload them, and you can't overload them. Alright, so I said that, yay. That creates me a pointer. Everyone agree? Just a pointer?
Yes.
Right? Nothing else except for a pointer. Alright?
With garbage value.
With a garbage value, right? It's pointing, right? If I wanted to draw it, right, it'd just be pointing off to who knows what. Right? Go ahead.
You're like, wait, no, I don't want that.
But I don't want that, right? So I want to draw it again, right? But what we can do is that we can use the word new. After new, we can give it a type, and this says create me a variable of that type. New in it creates me a what? An integer, right? New double creates me a double. Okay? It does two things. It creates the variable and it returns the memory address of where the variable is located. So if new int gives me the memory address, I'm going to store it into a pointer so the pointer points to that new thing I created. Does that make sense? As opposed to saying what? P1 gets assigned ampersand V1, right? Now it's P1 gets assigned a new int. So new int does two things. It creates me a new int, right? And it returns the memory address to P1, and so now P1 points to it. Are we good with that? So really the name of this variable is what?
New int or star P1?
Sorry. Okay. Right? To get to what a pointer is pointing to, we put the star on it, right? Follow the star row. Does this make sense a little bit? All right. I just want a little bit. Right? Now, star P1 is an integer variable, right? So we can do to it what we do to integer variables. Right? Which is always a nice thing.
Star P1 plus plus.
So, exactly. So cin star P1 says get from the user, store it into the variable pointed to by P1. Right? So someone gives me a value and we put 5 in. Good? And then I say the variable pointed to by P1 gets assigned the variable pointed to by P1's value. I'm going to take a right breath. All right, good. Plus 7. Right? A lot of words. So 5 plus 7 is what? 12, and we store it back into the variable pointed to by P1. Right, so this 5 becomes 12. You see enough? And so when I see out star P1, what do I output? 12. Makes sense a little bit? Okay.
That's the C out thing that P1's pointing to.
Yeah. The star says see out the value of the thing it's pointing. Got it. Dereferencing on. Which is one of your answers for or just question 1. Anyways, we just did this, so I'm skipping. Right, these variables that get created with the new operator are called dynamic variables. They're dynamic because they get created. Later on, we'll find out get destroyed at runtime while the program. Okay. Let's look at some examples of this. I hate to say it, but there's no real reason to make it like a dynamic integer, just make an integer. There's no real reason to make a dynamic double, just make a double. But it's leading to our last little bit of slides where the thing that we're going to create that's dynamic is actually very useful. Dynamic arrays. We're going to get to this. But let's just do some helpful things with this.
Are they helpful, like if you have things that are like queued up and stacked?
They're helpful when you're working with objects. So creating dynamic variables, not that exciting, not really much reason to do it. Creating dynamic objects, very useful. We'll create dynamic objects. Guess when?
Like,
Next class.
never mind.
Alright, so come back. We're going to do stupid this weekend, come back next week and we'll do more stuff. Alright, so all you do, P1 gets assigned a new int. Alright, so I can see out star P1, right, which right now is what?
Garbage.
Garbage, right, our favorite word. Right, garbage, yay, it gave me 0, what nice garbage.
We're not even gonna
Not
look at
guaranteed
that.
to give you 0 though, just understand that. But, right, before that I could have said star P1 gets assigned, right, at 42, our favorite number. And now I get 42. Because once again, after I do this, star P1 is just an integer variable. And do we know how to work with integer variables? Yes.
Mostly.
Right, so then we're good. Alright, you can do weird stuff like this. P2 gets assigned P1. Right, so when I output star P2, it should also output what?
42.
42, good.
Right, right.
Now that the pointers, I have 2 pointers pointing in the same place, I can take the P1 pointer and point to another new integer. Give it a value. Right, and see out it. It's nothing.
Nothing. So you're reassigning a new value to it?
Right, so what did I do? Let's draw it, right?
Would that have output the ASCII of the P2?
No, it wouldn't. It wouldn't work. It would have thought that I was doing something weird. That was. All right. So I created this. Right, that's line 10. Right, then I said star V1 gets 42, so I put 42 in here.
Yeah.
Right. I actually had a P2 variable as well. That was an int star. All right, and on line 12, I said it also points to the same place. Right? So then when I see out at star P2, I said follow P2 0, and I output in what?
42.
Right? Line 14, I said create me another new integer and store it into P1. So since I don't have a lot of room, right, I'm going to put the integer there, right, and I'm going to store it in P1, so this arrow's going to point to that new integer.
Well, that's technically star P1 now?
That's technically star P1, right? So this is not star P1 anymore, this is only star what?
P2.
Right, and this is star P1.
Sorry if that wasn't.
No, that's good. And then I put 52 in there. Right, line 15. And then when I see out it, I get 1. Make sense? Questions? I'm surprised that we're doing pretty good today.
Pointers that point to multiple things. The one thing I don't.
No, pointers only point to one thing. You can have pointers that point to pointers that point to things.
That sounds
And I will teach you that.
basically like taking a blue pill.
Right? It's always one less star, right? So an int star points to a what?
An int.
An int star points to a
Int star.
Right? An int star. Thank goodness we're not going to go there. Points to an int star.
The thing that confuses me is like where it's P1 equals new int, it just feels like it's backwards to me because we don't.
Right,
have
because then we
to
say
put-
int P1.
Yeah, so it's just like, can you do that with anything? It doesn't matter the order that they're put in.
Well, things to the operator new.
The new is a keyword, so it has to be on the right side given that sign.
Okay.
If you just said new int, it would create you a box. Right? If I just said new int, I'd get a box. If I said new int again, I'd just get another box. Those boxes don't follow scope rules, and they last for the life of your program. So they just eat up memory. So you always want to make sure that when you create a box, you store the memory address in some place. Good? Questions? No?
What is this for?
What is this for? Here, that's a good question. Let me show you. Right? And I'm going to lead you to my answer too, right? So let's see if this makes sense. Array variables contain the memory address of the array. Yes, agreed?
Yes.
Okay. First element, right? Where the first element is located. And memory addresses in C++ are pointers. Agreed? Right, this is like logic class, right? And so then we can do the little, anyone ever done this, the therefore thing? Anyone know what I'm talking about?
Wait, so memory addresses in C++ are pointers, but pointers point to memory addresses?
They hold memory addresses. They don't point to memory addresses.
They
They
hold.
store memory. They point to the variable that is located at.
Okay.
So, well, if array variables contain memory addresses, and memory addresses in C++ are pointers, then arrays must be what? Pointers, right? Want to follow that logic? Yeah? Good. Good. It's a good day. Right? It's a pointer, right? Which means that we kind of do to it what we do to pointers. Right? So let's look at this. In A bracket 3, remember I told you I was lying to you?
Yeah.
But then I said I
I
was
do
not
remember
lying.
that.
Right? How did I draw this before? I would create an array of size what? 3?
Yeah.
Right? Say that its type is what?
Int.
And then I just slap a name on top of it. Agreed?
I hated that.
Right? But if A is really a pointer, it's its own variable. Whose type is what?
Int. Start.
Thank you. And it points to what?
The element
The
0.
first element of the array. Does that make sense? So I can do something like this, int star p. Agreed?
Yes.
Are these the same types?
Yes.
Yeah? So they're both pointers, agreed?
So that's going to be a star star in one of them, right?
No, no star stars.
Oh.
Can I do this? Can I say P gets assigned the memory address that A stored? Yes,
Yeah.
and what am I really saying?
Give it an array of 3.
Not give it an array, but what? Point P
Point
to...
to the value that A holds, which is an array.
Does that make sense? And now that P is pointing to the same place as A, we can actually use P like an array, right? Which means I can do P bracket 0, right? If I said P bracket 0 equals 5, right? Well, where's that going to put 5?
In 0.
Does that make sense? Because actually P and A are the same thing now.
But with that, so that also will change what A is holding.
Yes.
It's not
Because
like
A is not an array. A is a pointer to an array, and P is a pointer to an array.
It doesn't change what it is.
Not what A is holding, but he's talking about the array. You're talking about A's array, right?
right. Like so, when you say that P bracket 0,
I'm gonna see out
that's gonna be what.
A bracket
If
0.
you now you could see out, you could do that and then see out A, and it'll also tell you that that's a 5 in there because you did it with the P. Okay, thank you.
Make sense?
So the memory location of element 0 is x01 both int star p and a contain 0x.
Going off what we learned that they take up 4 bytes a minute.
Right.
Well, great. Do I really want 2 names for one array? Still not useful. I've just been wasting your time almost.
I was thinking that I was like, I don't think you got to the
So
point.
you can do that. You can't go A gets assigned P. The reason for that is that this isn't just an int star. It's a constant star. Can you change constants?
Nope.
No, which is good because A should be dedicated to that array, right? A is a pointer for that array. It should always point to that array. Yes. Talking about either read only or something. Good so far. This is just the framework for what I'm going to do. All right. Dynamic arrays are similar to dynamic variables in the sense that you create them at runtime. Okay. Why would creating an array at runtime be useful? What can we not do with arrays right now?
Oh, you can't make them like not consecutive, or
Well, you can never do that though.
oh,
Huh?
Look through them?
No, we can look through them. Unknown, you can't have unknown size, right? When you create an array right now, you have to say, oh, it's a size 10, size 20, right? Can you get that from the user?
oh, like you'd
No.
have to make an array of, before this, we'd have to
Right.
make an array of 100 just in case a class size for
Exactly,
data
right?
had 78
Because it
students.
couldn't handle input at what? Runtime.
Right.
But now I'm saying that with dynamic stuff, you can create stuff at Runtime. So you can now create a variable of, or an array of any size at runtime.
You would just queue the user to enter the size they wanted. Okay.
So here's my example, right? I have a variable called size, right? I get it from the user. I'm gonna give the size at runtime.
Yeah.
Right? So I'm gonna give you a size.
43.
Yeah, so definitely 3. I'm not gonna make an array of 42, are you kidding? Right? Double star array. That just creates a what? Does that create an array?
No, this creates a pointer
Just creates a pointer, right?
that points to garbage.
Good. Right? An array whose base type or its type is what?
Double star?
Double star.
Double star, which means this is the first time where our pointer's not gonna point to an integer, but to a what? To a double. The cool thing about pointers is that they can point to a dynamic variable or they can point to a dynamic array. And it's the same syntax as far as creating the pointer. Right, so this pointer can point to a dynamic variable, and I'm gonna teach you now it can also point to a dynamic what? Array. Which I got the size of that array at
Runtime.
It's not much harder, right? What I taught you before was array equals new double. Right, are we good with that? And I just put bracket size. Right? How big do I want the array to be? This says create a new double array of size 3, because size holds the value of 3. Agreed? So I create my array of size 3. When I call new, not only does it create something, but it also returns the memory address of the thing I created. Right? And so we're going to store that into what? Array. And so in essence, array points to what?
The array.
First element of the array. Easy enough? Okay, this is the cool part. This dynamic array, does it look just like the other array that I created? The A array? Yeah, right? With a pointer pointing to, right, an array of some size, of some type. Which means that once you create a dynamic array, you use it like a what? Like a regular array. So after you do literally like these 2 lines of code, all the other code is all of the other code that we already know. Or we're learning because you're not done with code assignment for you. Right?
Would the array be a star array?
No. The star points to one less star. If this was a star array, then these would hold memory addresses that would then have to point to other things.
Alright.
Yeah. Always one less star. The arrow always points to something that's one less star. You lose some of your shine.
Okay, I got it.
As you do that. Right, which means if I want to put, right, I can say array bracket 2 gets assigned the value of 7. Right, which says put 7 in my array at index location what? 2. So I go here and I go 1, 2, and I put what? 7. But once you create the dynamic array, you use it like a regular array. Make sense? Couple things, right? Types have to match, right? That's what that's saying, types have to match, right? Pointer points to the first one, we see that on the picture, right? And then you need to dedicate that pointer to the array. Because if you point this pointer somewhere else, the array still exists, but you can no longer get back to it, okay? Pointers remember where something's located. As soon as you move the pointer, you've now forgotten where
Can you
buried all that
repoint
shit.
it that way though?
Huh?
Can you repoint it that way though?
Nope, you forgot,
Oh,
right? So you
I
lost
see.
your wallet today, you're never gonna remember where it is. Because you don't have any way to get back to it.
When you create a pointer and point it to, like you say, a new array, that just saves the array's memory address to the pointer, right?
Yeah.
If that array then is gone.
Well, when you say new array, like new double, that does create this.
Oh, it does?
It creates it and then returns the memory address of where it got. Yeah. point this away, this gets stuck there for forever. Until the program. And the context of the program.
Where do you start when you do this?
But if you write like a server program that's supposed to run 24/7,
You have so many
then it
files.
really gets stuck there.
No, it's just
Until the
these.
computer-
Those three?
So there's the assignment.
You don't edit this
Alright.
at all.
Yeah. we don't have this one.
Not only am I gonna
This
make a
one?
dynamic array, but I'm
You definitely
also,
wanna
if
use
you're
this
having
one.
trouble with output in
And
the
where's
code
the H
assignment, the comma separated output.
You have to write all of the.
Under name stuff. But this one's the above name. No.
Yeah.
This one's the above. Wait.
Alright, I create a pointer that can
That's
point
the
to
one that
what?
goes.
A string or a
think so.
string array, right? It could be
Second
either.
part.
Right, let's create size. Ask the user how many
This is
students.
above. Above name.
Yeah, the ones below
And
them.
this is under me.
Mm-hmm.
Get that from the user,
That's what the class is
right?
defined.
And here's really the only new thing. Students get assigned a what? A new, what's the base type of my array? String, and how many of them do I want? Good. 5 of them. Once again, this allows me to figure out the size of the array at runtime. Now the rest of my code is just normal array code. Whether we're good at it or not, this is not a new concept. This is review of an old concept. Okay? If I want to get to every element in an array, what do I need?
For loop.
Okay? Start I at
0.
0. Normally go I less than what?
Size.
Size, good. But because I said I want to comma separate my output, we don't ever put a comma on the what? The last element, agreed?
Right.
Yes.
So I'm only gonna loop to all but the last element.
Right.
And here I can just see out, right, my array students, right, at its location. What should I put in here? I, right? Sometimes students struggle with what do I put in the square brackets? Well, if you write a for loop, I is the thing that's changing, agreed?
Mm-hmm.
So I is what you want to put in the square brackets because I is the thing that's going to, every iteration, be a new value. Move you from element 0 to element 1, element 2 to our main element 2. Right now I'm going to add a comma. Now I've outputted all but the last value, agreed? So
Right.
after my loop, I can output students at what? Size minus 1, because the last element's always located at size minus 1. Huh? Does that work?
Yeah.
Let's find out.
Sure. You have to put in an input, right?
No, I
Oh,
have
okay.
that, right? How many students? About 5 students?
7.
7.
It's running slow right now.
555?
Not that many.
It's not a run slow before.
5 students. 5, oh.
Comma.
Well, I never
comma.
got it, did I?
Oh.
Isn't that funny? Right? I created, right? My array has, right, 5 students all with no names, because strings by default are the empty strings.
Oh, yep.
So I jumped the gun a little bit, because I need another for it, right?
Hmm.
And I equals 0, I less than size,
Swiss.
Huge.
I plus plus. Right? And this would be, right, see out, right, enter student, number, whatever, I plus 1. Name. I always hate how ugly see out statements have to look in order for them to like look nice on output.
Yeah.
CN, right, student at what? At I?
Yep.
Mm-hmm. Now it should work.
Shouldn't that be nested?
No, because it's not a 2-dimensional array. Right, just 1-dimensional array. One loop to fill it up, and then a separate loop to what?
Empty it.
To output, right? I'm not so sure I can come up with 5 names. Let's do 3 names. John, Jane,
Jacob Jingleheimer.
and Jacob. I hit enter, right? And I get John, Jane, Jacob.
Nice.
Isn't that so great?
Beautiful.
Right? We can do it again. Right, if I ran it again, I could do what? I could do size 10, size 20, size 30, right? I could dynamically create the size of the array at runtime to make whatever size. Right? You're like, I use that.
So there's no way for you to output those in a way that has like smallest to largest. Let's say those were our score.
You have to sort it.
Okay.
Yeah. So you want to output it smallest to largest, you would need to sort that. Which you'll learn next semester.
Oh, how dare
'Cause
you?
I'm thinking like, well, I've used a program where.
And find the max, like, you don't have to sort them all and it takes a lot of them, right? I gave you the max algorithm where you just say, the first one's the largest, compare the next one to that, if it's larger, it's the largest.
Right.
So no sorting needed. Not only did we get done, almost on time,
So you can help me with my.
right? There's not really much for me to say about the lab either, so
Yep.
I'm almost done. I'm gonna come back to 1, 2 through 5, or 2 through 6 is all about what is the output, okay? I recommend that you draw it, right? Use a whiteboard, right? Use paper and please.
I got it right here.
Right? But draw it out, see what's going on. And then question 7 says, write code in vain to create an array of variable size, right? The user will input the size to be created. Pretty sure I literally just did that, right?
Are you okay with this, like, putting in, like, asking for the variable?
Yeah. Yeah, you can spice it up a little bit. All right, let's look at question 1. 3 uses of the star operator that we have seen so far. Right, and I say name them and give me an example of them. So I'm going to help you name them, and then you can do the example. Sound good? What's one of them?
Multiplication.
Multiplication. Dereferencing is what we were hearing over here. Dereferencing operator, where we get the value that a pointer is pointing to. Third place? Creating, right? So declaration of a pointer. So declaration of a pointer, dereferencing operator, and the lovely what? Multiplication. So the star's like all powerful, right? It does different things depending on the context of what you Yeah, but with another.
So that's asking.
Operator.
Code is asking for like the operator.
Huh? No, it's not operator.
So it's asking for code. Is it saying just like write an example?
Yeah, like
Like
if your answer is multiplication, maybe not X because that looks like a star, but Y times Z.
right. Okay.
I'm looking for
Oh, I
program,
got
like, CT line program. No, I don't program. Just an example of where you use the stuff. Good?
Is it
Okay. So you have this lab to get done, but right also you want to kind of forward do tonight. Because maybe some of you are done with it, right? And you're all happy. Some of you aren't done with it. I would like to make you happy by the end of class. I don't know if that's possible.
dereferencing from the hand?
All right, go. I'm gonna stop talking.
It's like this, Chris. So like if you wanted to assign the memory address to V1, then that's
Right.
that's how you do it. I got a whiteboard right here, got a pen and an eraser. Ready to go. What is the output of the following code?
Only on the end? Okay, the first one works fine. The first time failed. You're doing almost everything right, but if you say int, that creates a new variable. Because otherwise, here, you create a local variable, you set it to 0, function ends, local variable. You never change the actual 35 variable. Okay. Yeah, I'm sure of that. Capital. And then yours must accidentally.
For number 2, doesn't new int mean that it's assigning the memory address for it?
Hold on, I might need to drop this. Okay, hold on. So we have.
Oh,
We have
I
two
wrote
variables.
those down. I wrote those.
We have 2 variables, and then we have 2 things that are going to be created
For this one,
on the runtime. New int.
because if your arrays are size 10, which you have 10 values,
Okay, so
so 10 equals 10 is full, right? So it's less than the capacity. Which makes sense, right? If size is less than capacity, it shows that meaning after size equals capacity. Okay.
So it's going to be 10 space 20, then 20 space 20, and then 30 space 20. That's what I see.
Yeah.
So I think it's like, okay, so your P1, P2, and then it's creating your 2 boxes, right? So it's pointing to those.
Yes.
And that's your first one, 10, 20. And then it's saying to
P1 equals P2.
give P1 the memory spot that P2 is.
So it's basically they're
So
both
then it's going to be
2020.
yes,
Yep.
like vision.
And then
And then now
P1
it's-
equals 30, so that's 30
right.
now.
So then it becomes 30, and that stays 20.
Yep.
That's what I think it says.
That's exactly what it is. Got it.
And the idea is that enter. Like the enter function is going to get all one.
Number 3.
So 2 new boxes.
Okay.
Well, no,
These are memory addresses. And then it sets up 2 new ones.
Wait, don't they say the same thing?
I think it's just set up different. Hold on. This is 10. It's 20.
Oh, you know what? It's reverse. So it's gonna be the same. So it's gonna be 1020.
2020.
It's going to be 2020, and then it's going to be 2030.
Yes. That's it.
You only added one thing.
Trying to trick us.
Yeah. What was it?
It's the same thing.
30.
Yeah. Now, there's a couple things, right? We have to, right?
Yeah. But I didn't find list size 20 was, I don't know why.
Well, no, this is the index, right? This is mine versus one of the index, right? Right, but we don't know where, right? We have to tell it.
Isn't it the same thing?
No, look. So this is,
Each time it's gonna be different.
it's this, Chris. Number 4 is that.
Wait, because this doesn't have an asterisk.
Yeah, I know. So it's
And these
assigning.
ones do.
Good, next time we're gonna sort it out.
Yeah, this is the memory address of P2, right? So the memory address of P2,
It's getting a new value.
yes.
And you can add that in.
So number 3 is correct. Number 4, what number 4 does is it assigns it assigns the memory address of P1 to P2. So that means it goes 2020 again. And the memory address of P1 is 30, so this is 3020. Or, yeah, that's it. 3020.
That makes
So I know that that's 10, that's 20.
list at the size.
I know that that's.
Now what happens to size?
It's giving whatever the new thing that's pointing to the value of 30, which is.
They're supposed to be part of the class or not?
Let's go to the one like what did you use again? You're always like, I'm exploding myself. Yeah. There's dereferencing, creating, and multiplication. Those are the uses. Creating. Creating, multiplication, dereferencing.
Chris, this is 5 right here. Because what it's doing,
Let me look, because I want to make sure I understand it too.
yeah,
And then I'll check. Okay, so.
This one's a friend? Okay. Oh, yeah.
Yeah, so 10.
Well, it's a friend. All friends? Just that one, the other ones are not.
Okay, so. Assign the thing that P1 thing's pointing to, the thing that P2
and then it becomes
is pointing to. So
2020.
that's 2020.
Yeah.
I'm trying to like put the verbiage in there so it makes sense to me in my head here.
The verbiage.
And now it's saying, assign the thing that P2 is pointing to 30. So that's going to be, it's going to be 3020 now.
No.
Yeah, because P2 is pointing to P1.
Oh, I see.
That's what that says to me, right? So assign the thing that P1 is pointing to, the thing that P2 is pointing to.
That makes sense.
Wait, okay, the thing that P2 is pointing to is a new int that's value 20.
Yeah.
Okay, so then the
And then
thing
it
that
gets assigned
P2 is
30.
pointing to gets 30, so then P1 doesn't change, P2 changes. So maybe you were right.
No, you were right, because if P2 gets assigned, if P1 gets assigned P2, right, which is 20, P2 changes to 30. So now it's 30-20. Or maybe it's 30-30.
These ones have access to the member.
It is 30-30. Because P1 was assigned to P2, and P2 changed to 30, so P1 is now 30, and P2 is still 30, so it's 30-30.
Yeah, you're right,
actually.
Yeah. I'm gonna double check, but yeah.
This one needs to be written down.
I am the compiler.
Oh, yeah, no, yeah, you're thinking of changing the address. So, yeah, no.
There's no reason to say if
Yeah, it's pointing
just create a variable.
Right now, it's probably just there won't be anybody.
Because, okay, so you have capacity, that's how many arrays. But then inside the array, we're building this list. So size will count. So that one's gonna start at 0.
So this is gonna be 0 through 9. So we're assigning the element, the first element in array size, which is 0. Then we're gonna say,
like the water's so
Wait,
clear.
1, 2, 3, 4, 5, 6, 7. And then 4. Yeah, so it's gonna be.
Run around and shoot it out. No, you won't get it until you come back in holiday.
I wouldn't trust me. It's super hard. 10, 20, 25, 30, 20.
Oh, sick. We should see like, oh, that 20, and then see what it does in the last one. We didn't, you probably did, I didn't pay attention, I'm like. So you taught us how to run with something on that pro debugger.
Okay, so.
I don't use it. I just trying to figure it out. I've It's 10, 20.
Okay, Chris.
20, 20.
Number 6.
30.
That's basically it right there.
Yeah.
I had to do all of this shit.
So you're gonna see out what the value of I is and put a space. So basically, this is saying the element is gonna be equal to wherever you are in the for loop.
Well, yeah, I
And
did
your
all
for
that
loop
already.
is 10, so it's gonna be 0 through 9 in your elements. So that's gonna see out. So this is gonna say, well, is I less than 10?
Yeah, that's what
Yeah,
I did
and
here.
0 is less than 10. So then we're gonna see out 0.
Yeah, so
Then
what
it's gonna go
happened
back.
was in the array, every spot was filled with a number except 10, because it's garbage. And then,
Well, it doesn't go to 10 because
No, it
0 through 9 is 10. That is K array size.
well, anyway, that's the terminal.
Yeah.
It's okay. I knew it was coming.
Because they compiled it in pretty much something.
That's good for doing up.
Like the number test, yeah.
I had.
I mean, you can use some of the code, sure. By all means, you can use some logic of what you have in mind.
It's pretty much the same program, I'm just also adding. It's, yeah, nearly that level.
Yeah, as long as you, it follows what I'm asking.
All right, thank you. And then, wait, more help, please. No. Probably ask about that. I don't remember that.
Alright, so one changes the arrow, right? P1 equals P2 says P2, which holds a memory address. That memory address is the same as P1. So basically, P1 now points to the same thing that P2 is pointing to. The star says whatever the pointers are pointing to, those values wouldn't change.
Oh, I see. It says twice. No, I just need to get
I don't know. I don't remember, dude. Because he's writing it differently. Because this isn't a P star or a P stars, so it's resetting P2. But he didn't change what these were pointing to in the middle here. So all you're really changing is what this is pointing to, and it's the new int value of 30.
Which means that my size variable is what? 2, right? 0, 1, 2, 3. Good. Now, the user's gonna give you a number, saying, I want the value at that number. And that number is off by 1. Right? Yeah, so let's do it as if you subtract it, right? So they're gonna say get element, right, 2, or really they're saying get element 1, right? So the valid numbers, right, would be these two numbers, right? So anything less than 0 would be invalid. Does that make sense? And anything greater than 1 would be invalid. Right? But obviously, if I had a number here, it'd be anything greater than 2. Right? So you have to use your size, right? So basically, if you've already subtracted 1 from the location, right? Location is less than 0, right? Or if location is what? Greater than or equal to 5. Those are your problems, right? That's when there's no item. Otherwise, you can just return a list bracket, right? No more than this.
Can you check my phone?
Location is less than 0, or location is greater than. That's it. But you, right?
Yeah.
You're right, yours is an element was like 0 next to you. So it's going to be easier to stay off minus. That's 1 by 1. So now when you return, we take their human readable form and bring it back to the program. But this is good, right? If an element is greater than equal to size, or element is less than 0, that's fine. Yep.
Okay, so is this really all you're asking for? Or am I?
And size, well, that's not a dynamic array, right? 38 is not dynamic. I'm gonna ask you to fill it out. Oh, wait. All right.
So if I ask you to put size in here,
Then you would say.
so I need to put the variable inside
You need
here.
a pointer, right? Anytime you hear dynamic, you gotta have to think you're creating a pointer to a new something.
So this would be just like that.
I would look at. Make sure. Say 20. I think it's 20. Dynamic array. Look at that. Right. We have pointer. Asks for size. Pointer equals a new string of that.
Oh, wait, okay, I'm missing the whole thing,
Yeah.
okay. Are you gonna, never mind, I'll ask you in a minute.
Okay. I'm not going anywhere at the moment.
Your shorts code. Shots code. Okay, your shots code. Good.
No, this is not equal, this is the value is not copied. They're both pointing to the same copy. We just copy the value. Basically,
But still, the change value of P2 shouldn't be lost.
I'll say what.
That shouldn't exist.
And then x equals 10, right? Y equals 20, right? value is, right? Because really, star or whatever is really just. Right, this isn't saying whatever happens to X happens to Y. That's not what that's saying. It's saying copy the value here. So when X is Y, still needs to be Y. With arrows, that's the X more. Right. What is it? Oh, because you're doing this with binary tree, right? Yeah, so count this time. It shouldn't be 0. But